Hello everyone, in this video I will explain how to find all odd numbers in an array using a simple algorithm. We will go through the step-by-step process and analyze its time and space complexity. Let's start. Let's go through an example to see how algorithm works. We have the following array of numbers: 3, 8, 7, 12, and 5. Our task is to find all the odd numbers in this array. First, we initialize an empty list to store the odd numbers. Next, we use a loop to go through each number in an array. Now, we check if the current number is odd. We do this using the condition num mod to not equal 0. If a number leaves a remainder when divided by 2, it is odd. If the number is odd, we add it to the list of odd numbers. We repeat this process for each number in an array until we have checked them all. So after running this algorithm, we successfully extracted all the odd numbers from the array. The final output is 3, 5, 9, and 15. This shows how we can use algorithm to efficiently filter specific values from a list. Initializing an empty list is a constant time operation. It doesn't matter how big the array is. The initialization of an empty list will always take the same amount of time. The loop iterates once for each element in the array, so its time complexity is linear, where n is the size of the array. The modulo operation takes constant time 0, 1, meaning it doesn't depend on the size of the array. Whether the number is small or large, the modulo operation will always complete in the same time. Since this check is performed for every element in the array, the total time complexity for all n iteration is linear. Adding an element to a list takes constant time, meaning it doesn't depend on the size of the list. Whether the list has 1 item or 1,000 items, adding an item takes the same time. Since this operation happens inside the loop, it will execute 0n times in the worst case when all elements are odd. The endf and endfor statements are just markers to close the conditions and loop. They don't contribute significantly to the time complexity. These are constant time operations, so their complexity is 0, 1. Returning the list is a constant time operation 0, 1. It doesn't matter how many elements the list contains. Returning it will take the same amount of time regardless of the list size. The total complexity is equal to 1 plus n plus 1 plus n plus n plus 1 plus 1. Simplifying, it's 3 plus 3n. So the final big O notation is 0n, since 3 plus 3n simplifies to 0n, which means the algorithm runs in linear time proportional to the size of the array. We will analyze the space complexity of finding all odd numbers. First, we have our input array 3, 8, 7, 12, and 5. Since this is given as input, we do not count it in a space complexity analysis. The size of the input is n is equal to 5, but we focus only on the extra memory used. Next, we declare an empty list called odd numbers. This list will store all the odd numbers found in the array. Since an empty list takes a constant amount of memory, this operation has a space complexity of 1. Now, we start a loop to go through each number in an array. To loop, variable num stores one element at a time. Since this variable takes only a single memory slot, its space complexity is 0, 1. Inside the loop, we check if the number is odd. Using the modulo operation, this operation doesn't require extra memory, so it has a space complexity of 0, 1. If the number is odd, we add it to the odd numbers list. The number of odd elements stored depends on the array. In this case, we store 3, 7, and 5, which is 3 elements. In the worst case, if all elements were odd, this would take 0n space. Finally, we return the odd numbers list. Returning a list does not require additional space, so this step has a space complexity of 0, 1. After going through the algorithm and its time complexity, we've successfully learned how to find odd numbers in an array. Thank you for watching. Bye!